This video covers the identification of an unknown metal by reaction with hydrochloric acid. The exploration 1 of this experiment will be performed as a demonstration to the class by your professor. In this video, we are doing the last part of this exploration first. We will have 3 test tubes, which we can either label or arrange them in a sequence. Your professor will fill the first tube with half an inch of deionized water, the second tube with half an inch of 1 molar hydrochloric acid, and in the third tube with half an inch of 5 molar hydrochloric acid. In all of these 3 tubes, we will drop a small aluminum metal piece almost at the same time. We will then keep these test tubes aside and start with the first part of the exploration. As you can see at the beginning, the aluminum metal is showing some changes with 5 molar HCl. As this demonstration progresses, you will be able to see more visible changes.
Now, add water. A little bit. And the first reaction, it's a sodium metal react with water. Okay, so I'm going to take a piece of sodium out. This will be too large, and then so we're going to cut it into my. Oh, now you can see 5 molars already started. All right, very well, beautiful. So now, and then place back, and now take a clean net. Okay. Get rid of all the mineral oil because that isolated the metal pieces from the air, because the air contains moisture, and then so we don't want that happen, right? And then now with your safety goggles on, and then place, and then on top, and then dip in. Now you can see this beautiful slow brown movement, and then the sodium metal getting smaller and smaller and smaller and smaller and smaller and smaller and smaller, and then finally disappeared. All right, disappeared. So now I want all of us to take a note of it, since we have just done the titration. And if I add a drop of phenolphthalein, see what will happen. Aha! Clear colorless solution now become pink. Now you need to tell me. Now the resulting solution is basic or it's acidic. All right, so that's the first reaction, all right?
As you can see, the aluminum metal has completely reacted with 5 molar HCl.
amount of water. Okay, like so. And this time, potassium is the metal. All right, very well. I hope they get a fresh potassium. Beautiful. All right, it's just about the same amount. And so, okay, watch what happened this time, all right? Ooh, pop, 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 pop. Much faster and much vigorous the reaction is, all right? Well, if you know your chemistry well, if you know your periodic table well, then you will know why, right? All right, so now, ladies and gentlemen, same thing. I will add one drop. Okay, now you see. All right, very well.
Your professor will now explain to you all the reactions that are happening and how to balance the chemical equations.
So, now, someone gets the electron, someone must lose the electron. Ladies and gentlemen, nomenclature is going to be on your final. What is this little creature? Sodium. All right, where is the sodium located? 1 is incorrect. 1A, yes, it's a metal. Under normal condition, like now, 1 atmosphere and then room temperature, metal lose electrons, become a metal ion, positive cation. Of course, lose electrons. All right. And then metal lose electrons. And then how many? Well, because it's 3A, therefore, IUPAC tells us the number of electrons being lost equals the group number, therefore will be 3. Well, the chloride right here is -1, so now you have a 3 here. Now, done. All right, so 3, 2, both from one source. So what's the lowest or smallest common denominator? 6, yes. And then in order to have a 6, how many? Need a 3. In order to have a 6, how many? You need to have a 2, and then you need to have 2. Finally, now you're balanced. All right, that's all.
This completes the exploration 1 of this experiment.